Okay, let's start with the tutor lecture. And this is actually in continuous from our previous lecture. And we already discussed the order and the molecularity. The What is the definition of the order and the molecularity? This we have already discussed. And in generally, in the previous lecture, we also discussed these reaction and the rate law. And today, actually, we will make some conclusions over the order and the molecularity, or we can make some differences between the order and the molecularity. So one by one, I am going to proceed with this one. Actually, what we have discussed, no, I'm just, it may be in the writing form, I'm going to write over here the difference between order and the molecularity. So by definition, simply order is the sum of the powers of all concentration terms in the rate law. This is the definition of the order. And for this, you must have a rate law, and rate law is given over here. If you have a rate law, then you just sum of the powers, like here it is the first, it is also first order, it is the four order, it is a second order, or it is a 3/2 order. And molecularity is actually the number of the reacting molecules in any of the elementary reaction. And let's suppose if these are the elementary reactions, that means these are the only reactions in the for these reactant to convert into the product. Then you can just define the molecularity looking at the number of the reacting molecules. Like in the first case, if it is elementary reaction, then it is one molecule of this and one molecule of this. So molecularity is 2, however, the order is 1. So this is just the revision of what we have discussed in our previous lecture. Now moving to this lecture, the difference between the order and the molecularity. And the first difference is order is an experimental value, because and you must write this rate law based on the experimental value, because you cannot write the rate law just looking at the equation. Let's suppose if I have written this rate law for this reaction, and in this reaction water is not there, although the water is in the reaction, without water this reaction is not going to happen. But rate law actually depending on the concentration of this molecule. So that means, how did I know that water is not influencing the rate of this reaction? It is based on the experiments. You can do some sort of the experiment, and you will apply some method to determine the order of the reaction. And this is our second phase of the lecture, and I am explaining very few the method in which you can determine the order of the reaction. But here, this is the only point to understand over here is order must be coming from the experiment. That's why it is an the experimental value. And of course, you can say the order if the rate law is written. That means you have to perform the experiment to write this rate law. When the rate law is written, then you can just see whatever is the power of all these concentration terms. That is called the order of the reaction. However, molecularity is a theoretical value. That means to determine the molecularity, in this case, there is no need for the experiment. So you are just looking at the reaction. If this reaction is written, and I have explained, if this is the only way for this reaction to convert into the product, that means this is the elementary reaction. Then you just look at the number of the molecules taking part in this chemical reaction, and there are one molecule of this, one molecule of this. That's why the molecularity in this case is the 2. So order is 1, molecularity is 2, because this is the experimental value and this is the theoretical value. That's why there may be the difference, and there may be the similarity between the order and the molecularity. It doesn't matter, but here we are going to explain which is coming from the experiment and which is the theoretical value. The second difference is the order may be zero, and it is one of the example is given over here. So these reaction and the rate law are very important to understand these differences between the order and the molecularity. So here, actually, the order may be zero. Like in this case, if it is this is the elementary reaction, water is not over here. That means the water H2O power H2O is having the power zero. That means order is zero. So whenever it is the power zero, that will be equal to one. That's why if you multiply by one, that the no way to write the multiply is one. So there is no need to write this one because this is not going to change. So the order in this case with respect to water is zero. So that's why you can say order may be zero, but molecularity is not equal to zero. In all of these cases, there should be some sort of the molecularity. As we have decided in the first case, the molecularity in this case is two. One is from this molecule, one is from this molecule. So the molecularity is two. So but the order may be zero. But here you cannot consider the water is having a zero molecularity. So molecularity is coming out whatever there is the number of molecules taking part in any chemical reaction or the elementary reaction. So the second difference is the order may be zero, but molecularity is not zero. The third point is order may be in fraction, and you can look at this rate law. We are not going to actually going to detail how it is written over here because it is we explain in or we you can study in the higher classes. But here only point is to understand over here, if this is the rate law, then the order is 3 by 2 as we have discussed before. So order may be in fraction. So this is the value in fraction. So that's why the order may be in fraction. However, molecularity is not in fraction. So you can look at all for reaction or any of the reaction. So there is molecularity may be one or more than one. Like in this case, there are the five molecules, there is a six molecules and one molecule. So none of the reactant or the product is having a fraction molecularity. So this is the third difference between order and the molecularity. Order may be fraction or molecularity should not be in fraction. The fourth point is the fourth and the last point is the order is very rare above third order. Usually it is very difficult to have the more than third order, although it is over here is 2 plus 1 that is the 4. But in majority of the cases you will find the order is below 3 or equal to 3. There is very rare to have the order more than 3. But molecularity may be above 3. This is a common practice. Like here it is given over here. There are a lot of chemical reaction. If you look at the chemical reactions, you can find there are more than 3. Frequently there are more than 3 molecules are reacting and forming the product. So these four are the basic differences between the order and the molecularity, and these are actually based on the observation we have written over here in the reactions and in the rate law. So this is all about the difference between order and the molecularity.